Hello everyone, once again welcome back to my channel. Today we are going to study force and laws of motion from class 9th physics. First, let's understand what is force. Force is a push or pull that changes or tries to change an object's state. And the SI unit of force is Newton. Examples of force: pulling a car, kicking a football, pulling a door, or lifting a book. Now let's see the effects of force. First, force can move a stationary body. For example, if we kick a football kept on the ground, the football starts moving. It is due to the force applied by our foot on the football. Secondly, force can make a moving body stop. It is a common observation that the football moving on the ground stops after some time. This is due to the friction force applied by the ground on the football. Thirdly, force can change the speed of a body. When we press the accelerator of a car, it speeds up. The engine force increases the speed. When we apply brakes, it slows down. This shows that the force can change speed. Fourth, force can change the direction of a body. For example, hitting a tennis ball changes its direction. The force of the racket changes the path of the ball. Fifth, force can change the shape of a body. For example, when we knead a dough of flour, it changes its shape. Now let's see what are balanced and unbalanced forces. First, let's take a look at balanced forces. But before that, we need to understand what is net force. Like there is a tug of war going on between two teams which have same number of players. One team is applying a force of 20 newtons, whereas the other team is applying a force of 50 newtons. It is obvious that in this case, the team applying the greater force will win. To find the net force here, we need the force of the first team and the second team and then subtract them. So with this we understand that the net force here will be 30 newtons. And the team which won was applying a force of 30 newtons more than the team which lost. Now let's jump back to the topic of balanced forces. When forces acting on an object are equal in magnitude and opposite in direction, they balance each other. The net force is zero and there's no change in motion. Let's understand this thing in a very simple way. So I'm going to take the example of tug of war. Let's say both the teams in this case are applying equal magnitude of force, which is 30 newtons. Here we can notice two things. First is that both the teams are applying equal magnitude of force, and second, that they are applying a force opposite to each other. Now, if you will try to find the net force in this case, you will get 30 minus 30, which will cancel out and will give you a 0. So our answer will be 0 Newton. And we know when the net force is 0, there is no motion, which means it is a balanced force. Now let's understand what are unbalanced forces. When forces are unequal, the net force isn't 0, which causes motion. And I have already given its example in the net force part, where we got a net force of 30 newtons and the first team won. Now moving on to Newton's laws of motion. Newton's first law of motion. So, to be concise, this law states that an object in motion stays in motion and an object at rest remains at rest until unless an external force acts on it. For example, there is a rolling ball and it will keep moving. It is never going to stop due to inertia. But when friction force is acted on it, it stops. Why? Because there is an external force of friction which is acting on the ball to stop it. Otherwise, the ball is never going to stop. Also, this is very important to note that when the mass of a body is very high, the inertia will be very high as well. Moving on to Newton's second law of motion. But to understand this law, we need to understand what is momentum. Momentum is the quantity of motion an object has. It depends on mass and velocity. Just think of it like an ouch. A moving truck has more ouch than a moving bicycle, which means a moving truck is going to give you more injuries than a moving bicycle. It is because the truck has more mass than the bicycle. But if you take an example of a gunshot, it is going to give you more injuries, of course, because its velocity is very high. So the formula to find the momentum of a particular body is P is equal to mv. Here P means momentum, m means mass and v means velocity. The more mass or velocity, the more the momentum. Now going back to Newton's second law of motion. The rate of change of momentum is directly proportional to the applied force. This simply means when the momentum applied on a body increases, the force applied on the same body also increases. Or when the momentum decreases, the force also decreases. For the representation of this statement, we have the formula for force, that is, force is equal to mass into acceleration. The SI unit of force is Newton, mass is kg, and acceleration is meter per second square. F is equal to ma tells us that force depends on mass and acceleration. Now moving on to Newton's third law of motion. This law states that every action has an equal and opposite reaction. Let's take some examples. First, swimming. You push water back and the water pushes you forward in order to make you swim. Or rockets. Gases push down on the land, whereas the rocket goes up. So we understand that action and reaction act on different objects. So this was it for now. Meet you in the next video.